Good morning, students. This is the continuation of experiment number 3, that is fourth bit, fifth bit. In fourth bit, relationship between two continuous variables. Okay, in that concept we need to study a covariance. What variance? Covariance. What is the main purpose of covariance in the sense? Just we use a regression analysis. Regression analysis is a group of made up of statistics with a data sets, with a data sets or vector. Just we need to take some variables randomly, so we need to create a models which describes the effect of variation in predicted variables on the response variable. What the main usage of covariance in the sense? Covariance, it is a statistical term. Mainly it is used to measure the direction of a linear relationship between the data vectors. Okay, what the main use here? To measure the direction of the linear relationship between the data vectors. Mathematically, what we should say, x and y represents the data vectors method. Just we need to define the type of method, to be used. Just we need to evaluate a covariance. Just we need to be compute covariance. Sometimes we say we have a categorical variable with values like male or female, yes or no, etc. So here the simple regression analysis gives multiple results, more than one result for each and every value of the categorical variable. Okay, so in such scenario we can study whatever the effect of categorical variable by using it along with the predictor variable, and just we need to be comparing the regression lines for each and every level of the categorical variable. What is the meaning of the categorical variable? According to the subject of our programming language, the code, let's check the code below. Just we need to convert the character variable into a factor variable in R. Characters are not supported in machine learning algorithm. The only way is just we need to be converted string into an integer. That is the main intention of categorical variable. Okay, the value is to be limited and usually based on a particular finite group. For example, we should take a categorical variable like countries. It can be countries, years, we can say gender, male or female, occupation, etc. A continuous variable, however, it can take any value. So here the effect of the categorical variable by using it along with the predictor variable, and just we need to comparing the regression lines for each and every level of categorical variable. And such as what we say, analysis is termed as analysis of covariance, also called ANCOVA, analysis of covariance. The short term here ANCOVA. Okay, here we see the correlation coefficients. What is meant by a correlation? First of all, we need to study about a correlation. Correlation allows to know which variable change in the evolve in the same direction. So which ones evolve in the opposite direction and which ones are independent. So in this correlation, I show how to compute correlation coefficients. And how to perform correlation test. And how to visualize. Listen carefully. How to compute, how to perform, and how to visualize the relationship between variables in our programming language. Just what the main intention correlation coefficient, or just it is a summary measure that describes what the extent of the statistical relationship between the two intervals or ratio level variables Just the correlation coefficient is scaled so that it always between -1 and +1, what I meant to say now, what is correlation? Just we need to allow which variable evolve which variables evolve in the same direction, which ones evolve in the opposite direction, and which ones are independent. So in this correlation coefficient, how to compute correlation coefficients and how to perform correlation test, how to test and how to visualize the relationship between variables in R. Here the range of a scaled correlation coefficient, it is always between -1 and +1. Just it is used to measure that describes the extent of the statistical relationship between two intervals, or we can say ratio level variables. Okay, here we seen plus 1.0, in the sense what the description of a rough guideline, perfect, positive, a plus association. Okay, and coming to the second thing, plus 0.8 to 1.0, very strong plus association. Plus 0.6 to 0.8, strong plus association. Plus 0.4 to 0.6, moderate plus association. Like that we need to study plus 0.2 to 0.4, in the sense what we can say, weak plus association, weak plus association. And coming to the next correlation coefficient, 0.02 plus 0.2, very weak plus or no association. Like that we are study about like that. Like that these are the coefficient relationships, coefficient what we can say, coefficient relations, how the coefficient relations it should be. Okay, now we can study comparing multiple, what we can say, comparing multiple correlations. Multiple in the sense more than one correlation, just we need to comparing, how to listen carefully here, how to calculate correlation between multiple variables in our programming language. Listen carefully. One way to quantify the relationship between two variables, the relationship between two variables is to use, listen carefully, is to use the default value Pearson correlation coefficient, which is a measure of the linear association between two variables, linear association between two variables. It always takes on a value between the scaled range -1 and +1, where here -1 indicates a perfectly negative linear correlation between two variables. 0 indicates no linear correlation between two variables. 1 indicates perfectly positive linear correlation between two variables. Just we need to comparing multiple correlations, multiple regression lines. What the main intention of comparing multiple correlation, in the sense according to the R programming language, or is a fundamental programming language, one way to quantify the relationship between two variables, just we need to use the Pearson correlation coefficient, which is we need to measure the linear association between two variables, linear association between two variables. It always takes on a value between the ranges -1 and +1. Okay, -1 indicates negative linear correlation between two variables. Okay, +1 indicates a perfectly positive linear correlation between two variables. Next we need to study about visualization methods. What methods we need to study about here? Visualization methods. Visualization methods in the sense we need to study about in the B part, categorical and continuous variables. Okay, categorical variable and continuous variables we are frequently used in R programming language. Okay, what is meant by categorical and continuous variables, in the sense we need to study factor in our programming language. Factor in our programming language is also known as categorical variable, so that it stores both string and integer data values. It stores both integer and string data values as per their level. So here a factor, what we can say, factor is mostly used in statistical modeling and exploratory data analytics with R. So in our data sets, just we can distinguish between two types of variables here. The first thing is categorical variable and the second thing is continuous variable. Listen carefully. In a factor in R, just it is a variable used to categorize and store the data. It have a certain limited number of different values. Just we need to store the data as a vector format of integer values. So the factor in R is also known as categorical variable that stores both the integer and string data values as per their levels. Okay, and just we can distinguish the two types, categorical and continuous variable. Here, look at here, categorical variables in R are stored into a factor. Let's check the code below to convert a character variable into a factor variable in R programming language. So here the characters are not supposed in machine learning algorithm, and the only thing is to convert a string to an integer data values. Okay, what I meant to say here, according to the descriptive statistics for a categorical variables in R, the value is limited, okay, and usually based on a particular finite group. For example, we should take a categorical variable in our programming language. It can be countries, years, gender, occupation. Already I said in previous video also. Okay. And coming to the continuous variable in the sense, however, it can take any values from integer to decimal point, from integer to decimal data values. So for example, we can have the revenue income, like price of a share, okay, etc. This is the categorical continuous variable. A continuous variable, however, can take any values from integer to decimal data values. For example, we can have the revenue and price of a share, etc. Okay, just this is the categorical and continuous variables. Now we are studied here two categorical variables. Okay, this is the syntax explanation. Listen carefully now here. All of you, look at this slide, all of you. Yes, it's now it is visible, I think so. Factor of x is equal to character of function, comma, levels, comma, labels is equal to levels, comma, ordered is equal to is dot ordered of x. Here we take some arguments. X is a vector of categorical data in R. Just need to be a string or integer and not decimal. Okay, this is the main intention of x argument. And coming to the levels, labels, ordered. Levels in the sense, it is a vector of possible values taken by x. This argument is optional one, so the default value is the unique list of items of the vector x. And coming to the labels, just we need to add a label to the x parameter categorical data in R. For example, one can take the label male, okay, while 0 the label female. Okay, 1 it should take the label male, while 0 it should take the label female. And coming to the ordered argument, what that is mean, just we need to determine if the levels should be ordered, in categorical data in our programming language. Okay, this is the syntax of two categorical variables. In that we need to study nominal categorical variable and ordinal categorical variable. Just we need to study about nominal categorical value. A categorical value has several values, but the order does not matter. For instance, male or female categorical variables in R does not have ordering. Yes, it does not have ordering. What the main intention of nominal categorical variable in the sense, a categorical variable in R programming language, it can be divided into nominal categorical variable and ordinal categorical variable. Okay, two types. Coming to the nominal categorical variable, it is a categorical variable, has several values, but the order does not matter. Listen carefully. But the order does not matter. It has also several values, but the order does not matter. Coming to the ordinal categorical value, in odd programming, server side programming, it is also an ordinal categorical variable. It is a type of categorical variable which has natural ordering, okay. Now we see here, just I can create a color vector, color underscore vector. Just I need to assign a CO function, in the sense which combine the elements into a vector: blue comma red comma green, white comma black comma yellow, whatever the colors you choose. Next we need to convert the vector to factor underscore color, that is a variable, okay. Just we need to assign that variable factor of color underscore vector, okay. Listen carefully. Okay, vector, we need to take a factor underscore color, like that. This is the syntax of the particular representation of nominal categorical variable, okay. Look at here, nominal categorical variable. This is the program. Just we need to create a color vector, color underscore vector, and then convert the vector to a factor. This is the syntax representation of nominal categorical variable, okay. Next we need to study ordinal categorical variable. It's what I meant to say, it is an ordinal, it is also odd programming, server side programming. It is an ordinal categorical variable. It is a type of variable which has natural ordering. Just we need to create ordinal categorical vector, day underscore vector. Just we need to assign some C function, evening, morning, afternoon, midday, midnight, evening. Just we need to convert day vector to a factor with ordered level, okay. Ordered level, we need to take factor underscore day underscore vector, order is equal to true comma levels is equal to C of morning, midday, afternoon, evening, midnight. Just we need to print the new variables of factor underscore day, factor underscore day vector. Just we need to print day underscore vector, evening, morning, afternoon, or midnight, whatever it may be. Just we need to print natural ordering, which has natural ordering. The last concept we need to study here, two categorical variables we need to study. Now we need to study two continuous variables. Now we will look at two continuous variables at the same time. Scatter plot is one of the best plot. Just we need to examine the relationship between two variables. Let's draw a scatter plot between age and a friend count of all the users. First, what is meant by two continuous variables? In the sense, the continuous variables are two types: instant variable and we can say ratio variable. The instant variable, in the sense, the variable that define the level, or we can say distance between each category, which is equal and static, are known as instant variables, okay. Once again I have to repeat, instant variable, just we need to define the level or distance between each category which is equal and static, are known as instant variable. And coming to the second variable, ratio variable, the variables having only one variation from the interval variable are also known as ratio variables. Here what the ratio variable says to you, only one variation from the interval variable. Here just we need to take at the same time we look at two continuous variables. Just we need to take some scatter plots. It is one of the best plot to determine the relation between two variables. Let's see the scatter plot between age and friend count of all the users. This is the graphical representation of the particular data, age and friend underscore account. This is nothing but a scatter plot, okay. It is also one of the best plot. We need to be determine the relationship between two variables, okay. This is nothing but a graphical representation of two continuous variable, okay. This is the continuation topic of experiment number 3. Is there any doubts regarding? Can you please contact me? Thank you, ma. Thank you one and all.